In the last clip, we had a look at multiplying and dividing vectors and how they look on an argand diagram. In this clip, I would like to refer to a few specific situations. Let's consider the complex number z. And let's have a look at what happens when we multiply it by I. So z is x plus iy. When we multiply this by I, we end up with I times x plus I squared y. Now I squared is -1, so that's negative y plus I x. So what does this mean? This means that my new vector has an imaginary value which is equal to the real value of the original vector, and it has a real value which is equal in magnitude to that of the imaginary of the original vector. So let's draw a vector. So here's our vector x and y. What is going to happen? So my new real value, so along the real axis, it will be of the same magnitude as y, but negative. So that would be negative y. And our imaginary is the same magnitude as the old real, so around there. So the resultant vector is up here. Now, if you think carefully about that, that's a rotation of 90 degrees. The magnitude of the original vector, the length, is given by square root of x squared plus y squared. And since we still have x and y, we are going to end up with a vector of the same length, x squared plus y squared. So the only change is the original vector would have had an angle of theta, the new vector has an angle of theta plus 90. Another case to be aware of is what happens when our vector x plus iy is multiplied by a constant k. Well, that changes the real and the imaginary component of the vector by a factor of k. So as a result, the angle will remain the same. Remember that the argument of a complex number is given by its inverse tan of imaginary over real. The k's will cancel and you end up with just y on x. But the modulus of kz is given by the square root of real squared plus the imaginary squared. We can take a factor of k out, and you can see that the length of the vector increases by a factor of k. So there are a couple of cases to be aware of.